Making my circuit boards nice and neat. Wonder if Kitty will give me a treat. Making a good beat, making a good bass line, making a great chord patch. Other sounds to match. Let's do it. Let's make it. Sample the keyboard coming. Ain't gonna fake it.
Right, I think it would be a good idea to explain what's going on with this ISD 1820 sampler. Now, before we begin, actually, even you get these circuit boards online that are advertised with the big chip on them, ISD 1820 with the big chip on it, but then they mug you off and rip you off, and the picture that you saw was something with a big chip on. I know that the resistors are different values and they don't have them along this end, like, so this is a different board. So what we end up with is the dinky one, which is absolutely shocking. You can't change the resistor value which is on this end, and it's not even a resistor on that end either, because it's clearly a capacitor instead. It should be R1 and a big chip, but if you go ahead and try to order these, don't even bother, because you're just going to get ripped off and end up with this version. I think years ago you could get the chips, the bigger chip board, but you have to buy these now as single chips and build your own. And sure enough, I mean, I've got pins on here to like put the resistors on, and I've also got myself 4 different octaves which I've added onto this board so that I can choose octaves, but I may actually negate to use that because I built this resistor board, and each of those pertains to one of the 32 notes that are on this keyboard, which will be housing this keyboard. Now what I've done is I've took the black panel and popped it into another keyboard here, because they all have this same shape to them, yeah, and this black one. So I made this metal panel to fix an effects unit on, which will be a reverb unit with 100 effects, 2 dials, one for an encoder which you select the reverb effect with, and then the other one will be just like a kind of set, like a gentle mix level or such. But I can make a mix level with a let's say a potentiometer. So I'm building the ISD 1820 to create my own thing that works with a resistor, so I can change the pitches that will connect into the resistor bank. Now what's going on with this is that I put a 5.08k. It's got to be spot on as such, because all of these are dependent on that being that value, because it'll offset. Without this resistor, none of these pitches will work properly. Now the reason why I put this resistor in there is that when I switch over to a light dependent resistor for my LFO, which will be, this is 3 to 5k, and it dips down, and other resistors, light dependent resistors that I have, will dip down from 5 to 8k, which is the next value up. So this is the lowest value light dependent resistor, and I'll be putting the next value up after that, and I will post more on about what values are which. Here we've got like a switch debounce. Now I found out that just by plugging a connector switch and tapping it between the play E function, which is the one where you press the button and when you release it the sound stops playing, because this is what you want when you're making a keyboard with all of these two-way micro switches. So yes, a 3.3k resistor and a 104Z capacitor. So the 104Z capacitor is 100 nanofarads or 0.1 microfarads, I believe that is UF. Now these switches are two-way, so what I'm doing is building my common line all the way along. All these 32 push switches will be joined in the center pins for common, and then all the other legs that make contacts on the other sides, they will also be all joined. This side of the switch is just for sake of basically pushing the button to start the sample. Then on the other side of the switch, each of these switches will go through to a pin corresponding to the pitch on this, which I have not necessarily painstakingly done, because I've done these before for a tape mod that I was working on, and I've lately bought some cassettes that are smaller in length so that they don't snag, because the longer cassettes don't seem to work well when I'm doing a tape mod with the motor PWM speed controller, and yeah, and hacking that speed controller with the resistors. So yeah, two sides. These are double throw single pole switches, because you only got a single switch after all. So a push button switch is only single pole really, but the throw is double, so you've got two circuits that you control with each switch. So yes, unfortunately I have to wire commons between two pins on every single switch, and then take those two wires just to this here, but in between the switch. So really I will mount this capacitor between the two pins. Now the bottom row of pins is live, and the other pins then go to the chip to send the live messages through that side of the chip onto the corresponding pins underneath, which is not looking too bad actually. It's not a very messy job. I think I will be selling these actually on the likes of eBay probably, or Amazon. Well, not Amazon, but I'll be doing them on eBay or Vinted. So I think I'll opt to sell my wares on Vinted. I like that place actually. It's where I get my keyboards for circuit bending. Now circuit bending was a thing really which is like kind of like an accidental horror show really, when you're licking your finger and sticking your tongue all over the circuit board and to get some crazy effects and stuff. And you only want to do circuit bending when you're powering something by batteries, and actually underpowering something is a very good idea too, because then that way you won't be likely to cause any damage to any of the components that are on the circuit board, and you might be able to find the mods a lot easier. So underpowering an object, so if it's 4.5 volts, I try to go to 3.7, and I use one of those blue coated usual lithium batteries. I don't know when it's doomed to explode on me yet, but there'll come a point when this thing will actually ignite itself and explode in whatever device I put it in. But if that's the case and I'm going to use one of these bad boys, then I'll be coating that in a nice little metal casing, so that if it does catch fire it won't actually burn or destroy. A beautiful piece of work, and a creative piece of work. But this is going to have an effects unit at the center, some dials there to control pitch, etc., and a LFO. So a lot of the stuff I'm making really has got a stupid and child friendly Hello Kitty kind of vibe going on, and I kind of like it because it makes circuit boards look less boring. It gives it identity, and plus I think it looks cool. Anyway, this is a vactrol which I made for this particular board, which I designed, and I have quite an array of cabling behind here, but it works, so there's no shorts, and there's a reasonable distance between solder joins as well, because I have this wonderful magnifying glass thing which actually improves my my working, in the sense that I am doing something more precise. And again, I use these blue pinouts for resistors, because the resistors are blue, and it gives me an indication of what they are. Well, not that I need to know because I build these things, I know where they go, but it's just a theme that I run with, and it helps me see things much clearer. This is pins that have been mounted on, but soldering onto those and heat shrink tubing them is a better option for me to connect wires to, and it makes more of a secure connection. But just be careful of heating the heat shrink tubing around your solder joints, and make sure your solder joints are strong, because heating the heat shrink tubing around solder joints will probably melt the solder and make the cable come out. So pulling on the cable or anything like that's a no-no when you're heat shrinking. And I just light it very quickly and then back off, light it again, back off, and it seems to work really well for me. There's always these knacks and tricks and that you find along the way when you're designing stuff like this. I've got a trim pot on the end here, which gives me the ability to change the brightness and drain as well of the constant on LED, which is the smokier one here. The other side I have two normal flashing LED lights which are clear, and the smoky one seems to emit more light for some reason. And now how I do my vactrols, which is what this thing is here, I'm sure a lot of people know, and this has got actually two light dependent resistors in, so the yellow and green responds to the lowest value of light dependent resistor, and then the blue and purple wire here, doesn't really matter what the colors are, but I remember for this particular vactrol. And then we have the pins as well on the end, of which I crimped and put on myself. I like doing that. I got good at doing the pins and crimping and all the DuPont stuff. However, in between here is what a lot of people do when they're making the vactrols, is they fail to put in a piece of well, what do you call that, semi-translucent plastic. But when you see light through this plastic, it creates a smoky haze, and you want the light to create a smoky haze in front of the light dependent resistor, because it polarizes the light and spreads it across better. So the light, the LED actually talks to the light dependent resistor a lot better with a piece of smoky plastic in there, which you'll see sandwiched in there, and it works a treat. Yes, going back to the switch debounce, maybe it might have been on my particular design, but on these boards, when you stab away at the play, well, that's just play loop, but they're the wrong way around. Play E should be this side. These boards are pathetic. They're ridiculous. Don't buy these. Do not buy these. Buy a kit and build your own one. You'll be better off, because you just get mugged off and ripped off and end up receiving one that doesn't have the full size chip like this guy here, ISD 1820 chip, and it should have that on it instead. And look, in contrast, the comparison, look at the size difference, and this one's got an extra pin, 2 pins on, so it's got 16 pins on instead of 14. So you want the one with 14 pins on, and providing you're going to get a genuine chip as well. It's a minefield this day and age buying anything now. But across the contacts of the switch, the capacitor, and then on one leg you have a resistor, and on the other leg just a normal wire, and then they'll connect onto these 2 pins. And as I said on one of the videos, that the bottom row is live, and then that sends the message across. Now when I was using this push button, doesn't really matter which push button you use, you get switch the bouncing, which really is just that when you push down it should make contacts, but in reality when it comes to a micro switch, there is a ripple. And over the period of microseconds is where that ripple happens. And because this is analog and it's electronics, analog electronics, that time duration is very critical. So what we do is we smooth out the button press by using the capacitor with a resistor, and after that I was able to without the whole sound playing. See, when we got the ripple from the bounce on the switch without the capacitor and the resistor, what was happening was, well, it was playing the whole length of the sample. I might be able to demonstrate that later, but it's pointless. I might as well best to describe it. I don't really like demonstrating stuff too much, because that's when it's an invitation for things to go wrong and a headache and stress gets involved. So let's not do that. However, so we've described pretty well, I think, what's going on here and why this stuff is relative to everything, in terms of components and their values, and why I'm choosing them. Now, as you see, the light dependent resistor is going to dip down to like 3K, but when the light is full on, with the lowest value light dependent resistor, what happens is it just passes most of the signal through with hardly any resistance drop. But when that light drops down, then you start to get higher resistance values, and that could throw this keyboard off regarding the tuning. And so when I start playing different notes, they won't be chromatically tuned. I want the wobble of the oscillator on the LFO between 3 and 5 K, and that's enough. And then when I use the switch to get away from this 5K resistor, then I will be going on to the LFO here, which is an NE 5x5 timing circuit. And I've got a couple of diagrams for the LFO and the sampler, and I'll put them on my video.
Let's make it! Sapper keyboard coming! Ain't gonna